Case 4. The particle is having a constant positive acceleration. How to draw the three graphs in this case? Since the acceleration is positive and constant, hence the acceleration time graph is easy to draw. The graph for acceleration will just be a horizontal straight line but above the time axis since the acceleration is positive. Hence, the acceleration time graph will look like this. Now, from this, how do we draw the velocity time graph? So, all you need to remember is acceleration is nothing but the gradient of a velocity time graph. Acceleration also do remember is the rate of change of velocity, and rate of change of velocity is nothing but the gradient of the velocity time graph. If acceleration is constant, that would mean that rate of change of velocity, which also means the gradient of the velocity time graph is a constant. Hence, the graph for velocity needs to be a straight line with a positive gradient. Hence, the velocity time graph can look like this. Here we have assumed that the initial velocity of the particle is zero and then the velocity is increasing at a constant rate. Why constant? Because the acceleration is constant. And then coming to the most important displacement time graph, how do we draw that? Now, in order to draw different kinds of graphs, it's important if we can figure out the correct equation. So in this case, if we can figure out the equation for displacement, that will help us draw the correct graph. And how do we do that? We are going to use the Stewart equation. So let's use S is equal to ut plus half at square, where S here stands for the displacement. In the velocity time graph, we have assumed initial velocity is zero. So let's put u as zero and acceleration is positive. So let's write it as it is. So the equation will become S is equal to half a into t square. And now, if we analyze this equation, displacement is on the y-axis, time is on the x-axis. So S is y, a by 2 can be considered another constant. Let me write m, and t is on the x-axis. So we will write x squared. So S is equal to half a t square is of the form y is equal to mx square. Y is equal to mx square is a quadratic equation where the coefficient of x square is a by 2. A is positive, which means we can say the coefficient of x square in this quadratic equation is positive. Now, please do remember the shape of the graph for a quadratic equation is always a parabola. It's either an upward facing parabola or a downward facing parabola. It all depends on the sign of the coefficient of x square. So, in this case, x square's coefficient is m is a by 2. A is positive since we have considered the case where acceleration is positive. If A is positive, that means the coefficient of t square, the time squared, is positive. Hence, the shape of the graph of this equation will be an upward facing parabola, and hence the displacement time graph can look like this. But how do we draw the displacement time graph depends on which point are we considered as the origin of the motion. In this graph which I have drawn, we are assuming that at time t is equal to 0, displacement is equal to 0. So the particle will start from the origin and then it will start moving in a particular direction at a velocity which is increasing at a constant rate. And from this point onwards, please remember the shortcut. Whenever the acceleration is positive, the graph of displacement time graph is an upward facing parabola. But if the acceleration is negative, then the shape will be a downward facing parabola. We are going to consider that case as well. But the graphs which I have drawn here, this is one sub case valid for a constant positive acceleration. We can draw another set of graphs for the same thing, constant positive acceleration. Since the acceleration is positive and constant, so the acceleration time graph will look the same. It is a horizontal line above the time axis. And like we discussed in the first sub case, since acceleration is positive and acceleration is nothing but the gradient of a velocity time graph, which means the graph for velocity will be a straight line with a positive gradient. In the first case, in the first subcase, we had assumed that the initial velocity of the particle is zero. That is why the graph is starting from the 0 point. But we can also draw the velocity time graph like this. Now, this graph is also a straight line having a positive gradient. But the only difference is at time t is equal to 0, velocity is not 0. It is having some non-zero value, but it is negative. So if you read this graph, what actually is happening at the origin, the particle is moving with a negative velocity, which means it is traveling towards the left-hand side. But analyze the graph, the velocity keeps reducing until it becomes zero. So the particle is traveling to the left hand side until it stops and then it reverses the direction. Why is it reversing the direction? Because look at this point where the graph is cutting the x axis. A point to the left of this point will be a negative velocity, and a point to the right of this point, let's say consider this point, the sign of velocity is positive here. At this point, since the sign of velocity is changing from negative to positive, we will say that the particle is changing the direction. And once the particle changes the direction, then it travels towards the right hand side, because then the velocity is above the x axis. Coming to the displacement time graph, please remember the shortcut. Since the acceleration is positive, the shape is going to be an upward facing parabola. So the displacement time graph can look like this. And like I explained earlier, displacement time graphs might look differently depending on which point are we considering as the origin. Initially, we had considered origin as the point where displacement is 0 at t is equal to 0. In this case, we are assuming origin as the point where at time t is equal to 0, displacement is positive. And hence, depending on the origin, we can have different displacement time graphs. But do remember the basic, the shape is not changing. In both the cases, you can see that the shape is an upward facing parabola. And why is it upward facing? Because the acceleration is positive. So these were the graphs for constant positive acceleration. The next case is if the particle is moving with a constant acceleration but negative. Now we can very easily draw the graphs. Since the acceleration is constant but negative, the acceleration time graph will be a straight line, a horizontal straight line, but below the time axis. It is below the x-axis because the acceleration is negative. For velocity time graph, let's try to use any Stewart equation. So if I use v is equal to u plus at, let me write v is equal to u plus a into t. For now, if I assume initial velocity is 0 and acceleration is negative, so let me write negative a into t. So the equation becomes v is equal to negative a into t. Velocity is on the y-axis, time is on the x-axis. So velocity is y, time is x, and the constant negative a will be the slope. And y is equal to mx is a straight line passing through the origin. But since the value of slope is negative a, the acceleration is negative, so the slope is negative. Hence, the velocity time graph will be a straight line passing through the origin but with a negative gradient. This velocity time graph is valid if the velocity at time t is equal to 0 is 0. For a displacement time graph, do remember the shortcut. Since the acceleration is negative, the shape of displacement time graph will be a downward facing parabola and the graph will look like this. Here again, the origin point is important. So at time t is equal to 0, we have assumed the displacement to be 0. And since the shape needs to be a downward facing parabola, that's why we have drawn a graph like this. So this is one set of graphs which we can draw for a constant negative acceleration. But remember what we had done in velocity time graph, we had used the assumption that at time t is equal to 0, velocity is 0, which might not be the case, which means let us try to draw a different set of graphs. Acceleration time graph will remain the same. The graph is a horizontal straight line below the time axis since acceleration is negative. For the velocity time graph, in the previous subcase, we had drawn a graph passing through the origin with a negative gradient. The graph was passing through the origin since we had assumed that at time t is equal to 0, velocity is 0. So for now, let us assume that at time t is equal to 0, particle is moving with some positive velocity. In that case, the graph will look like this. As you can see, at time t is equal to 0, the particle is having a positive velocity, and also the gradient of this line is negative, which needs to be true since the acceleration is negative. Let me repeat the process. Since acceleration is negative, acceleration is the gradient of a velocity time graph. If acceleration is negative, so the gradient of a velocity time graph needs to be negative. Coming to the displacement time graph, we know since acceleration is negative, shape of the graph needs to be a downward facing parabola, and hence the graph can look like this. Now, in the exam situations, how do you draw the correct displacement time graph? We know the general shape, it needs to be a downward facing parabola. But which graph is correct? At time t is equal to 0, velocity is 0. And from this graph, you can see velocity is negative and it is constantly increasing. Negative velocity means the particle is traveling to the left hand side. If the particle travels to the left hand side, the sign of displacement will always be negative. Will be negative, and that is why you can see in the graph of displacement after time t is equal to 0, displacement magnitude, although it is increasing, but it is increasing in the negative region. And why displacement is negative? Because the particle is traveling towards the left hand side. In the second subcase for the velocity time graph, we can see at time t is equal to 0, particle is having a positive velocity, which means at the origin point, the particle is actually traveling towards the right hand side. Now, if you observe the velocity time graph, with the passage of time, velocity keeps increasing until it becomes 0, which means the particle is traveling to the right hand side. It keeps slowing down until it stops, after which the particle will reverse the direction and then will start moving in the opposite direction. Why is it moving leftward? Because look at the graph, velocity has become negative. Let us analyze the displacement time graph. So we had deduced that at the origin point, the particle is traveling to the right hand side. Since the particle is moving to the right, so the sign of displacement will be positive. Hence, we have drawn the graph above the x-axis. So the particle keeps traveling towards the right hand side until it stops. And the point where it stops is this point on the graph. So this topmost point in the displacement time graph will be that point where the particle is changing the direction. So at this stage, the particle changes the direction. It starts going to the left hand side, which means it is going back closer to the origin point. Since the particle is traveling back towards the origin point, the value of displacement will now start to reduce, as you can see in this graph. So this was the in-depth understanding how to read the graphs, but in an exam situations, all you need to remember is if acceleration is positive, shape of displacement time graph will be an upward facing parabola. If acceleration is negative, then that shape will be a downward facing parabola.